Okay, recording is on. So, are there any questions you want to get answered? Did you have some questions?
I did actually. So for the units, do you care about if we include units or not?
Yes, I care about units. It's the most important thing I care about in my life.
Okay, but like in the tables, do you want like to have the units like?
Well, it generally it's good to include units in wherever it is needed. If you do the entire problem without units, that's not preferable, but it doesn't have to be at every place.
Okay. And then how do we find the error for the graphical method again?
The graphical method doesn't really have an error component. It's just as good as the resolution with which you create the graph.
Okay.
So if you had step length of delta x, then your error is pretty much delta x divided by 2.
Okay.
It's resolution divided by 2. Okay, so since we are also recording, I might as well do a few example problems. Is there any particular example that you want to see being done? 8.35. Thank you. 8.35. Oh, in your edition. Okay. Yeah. I need to pull up the book here. Yeah. 8.35. Real mechanical systems. Is that the problem statement? Yes. All right. So let me share the screen here so that people can see. All right, share screen. All right. So real mechanical systems may involve the deflection of nonlinear springs. In figure 8.35, a mass m is released a distance h above a nonlinear spring. The resistance force is given by. So if you just had F equals K1 times D, what does it make? That's a linear spring that follows Hooke's law. What we have is a nonlinear spring that also has dependence on D to the 3/2. And conservation of energy can be used to show that the relationship between D and H follows this equation. What are we asked? We are asked to solve for D given the following values for K1, K2, M, G, and then H. So everything else is known except D, which is D power 5 by 2, D squared. Even if this weren't here, this will not be a real problem for you. This is just a quadratic. Now we have a D power 5/2, so it's a nonlinear equation. All right, let's solve this problem. So I'm going to copy this before I turn it off. So we want to write 0 equals 2K2 divided by 5 times D to the 5/2 minus or plus half K1 D squared minus MGD minus MGH. K1, K2, M, G, H are all given. The only unknown is B. Okay, so this is a problem that is a very good candidate for Newton-Raphson. If this were given to you in the exam without specifying what method to use, I look at this right away. Computing the derivatives of this function is easy. So it's a good candidate for Newton-Raphson. Okay, let me turn off the. Good candidate for Newton-Raphson. So I need to write a table or I need to compute. So if I define my f of d as 2k2 divided by 5 d to the 5 halves, or I'll just, plus half k1 d squared minus mgd minus mgh. What is my derivative? F dash of d is k2 times d to the 3 halves plus k1 d minus mg. And for you as well as whoever is seeing the video, in exams, I strongly recommend the following kind of organization. That is, you want to keep it neat and clear so that you don't get confused in the first place. So this is iteration number. Okay, this is the value of b, and then f of d, and f dash of d, and then d in the next iteration. Or if you want, you can call this current iteration and next iteration. Okay.
Just out of curiosity,
Yeah.
why do you call the F, I think it was IX in your graphs? Or, yeah, it's like F and then parentheses I or XI.
Xi is basically X current value. You can call it Xi or D current or X current, it's just a name. So I start with iteration 0, which always starts for initial guess. Okay. And then my D current value or iteration number 0. My D current, that is what is a good guess for my D value?
Did it give us any bounds in the problem?
Say it again.
Did it give us any bounds that we would like in the problem?
Let me quickly check. In the problem statement, it says the resistance force of the spring is given by F is scaling with D. So I'm going to go with a guess value, which is H divided by 2. Because H is a relevant length scale for this problem, I'll just take H over 2 as an initial guess. You can take H over 4 or H over 3, doesn't matter. And then what is F of D? What is F dash of D? Okay. Now they've also given real values for these K1, K2, etc. So if I write those K1, K2, M, G, H. So this is where having units is very important. K1 is 40,000 grams per second squared. K2 is 40 grams per second squared per square root of meter. 40 grams per second squared meter to the half. M is 95 grams. M is 95 grams. And then G is 9.81 meter per second squared. And H is 0.43 meters. Okay, so my initial value I'm going to say is H over 2. Initial guess, which for D, I'm going to take that to be H over 2, which is 0.43 divided by 2. So just to keep it here, meters. Now comes the hard part or messy part where you have to compute these derivatives. or you have to compute these values. You have to actually punch in the numbers and get the values. Let's see if there is any simplification. Probably. Yeah, these textbook writers really don't like you. Trying to see if
It's simplify.
how.
If you plug in all your numbers for your givens, you could simplify a couple of these.
Okay, let's try that. So 2 times what is K2? 40 divided by 5 times d to the 5 by 2 plus half K1, which is 40,000 times d squared minus m is 95 multiplied by 9.81 times d.
Would you want to simplify 95 to kilograms, or would you keep it in grams?
I think it's okay because the left side is 0 and you can divide everything by 1,000 to turn this into a kilogram value. That's also acceptable. Either is fine. Then 95 times 9.81 times h, which is 0.43 meters. What can we simplify here?
You can combine all of your constants. So like
Sure.
95 and
So you can write this 16 d to the 5 halves plus 20,000 d squared minus what is 95 times 9.8?
931.95.
931.95 times d minus, you'll also have to multiply that by 0.43.
$400.73.
400.70. Thank you. 400.70. So that is your f of d. And f dash of d, if I take the derivative, that would be 40 times d to the 3 halves plus 40,000 d minus 931.95. This is good. D next iteration or D next equals D current minus f of D current divided by f dash of D current. This is the main formula. Newton-Raphson formula. Now I want you to check whether I got the numerator and denominator right. I have a habit of flipping them. You just look at your textbook, you can tell me if I wrote this right or wrong. Right? Okay,
Yes.
thank you. So use that formula to compute D next. And to be systematic, it will be helpful if you substitute 0.215 into f of D and f dash of D, put these values so that you can easily calculate the next value without making mistakes. So I can also put this in an Excel sheet. So I have iteration number. So this is problem number 8.35. So please do this. In the meantime, let me also do this on Excel and give you values to cross check. D current, f of D, f dash of D, D next. And then we want to do like a difference or absolute error and relative error. 0, D current 0.215. I'll get them. You will keep working. I'll get it. D for D is what? 2 times K2 times K2 divided by 5 times D to the power 2.5 plus R K1 D squared minus M G times D. Just trying to automate this fully, so give me 2 minutes, I'll be with you. K2 D squared MG. Almost done, just give me 1 second. All right. All right, I'm done. Yes.
So. Result for. When you're solving for I.
Can you be louder because it's getting recorded?
When we're solving for IX plus 1, we're using that formula, right?
Yep.
Okay.
Yep, xi plus 1. Yeah. All right, so what value are you getting? Were you able to do 2 or 3 iterations?
Getting 0.1667.
Correct. That's what I'm also getting. So if you, since I have the values, I can write it out so that you can cross check. We have f of d equals 323.7352, right? 323.7352, and f dash of d being 7672.038. Okay, and the next value of d being 0.1728. 1728. Were you able to get these values? Those who are trying on pencil and paper. Remember, in the exam, we have to do this on pencil and paper. And also remember, I am not the one taking it. I will be done it. Are you getting this? All of you? Those who are trying, you getting this? Okay. So then, the next value, that is for the second or the first iteration, the D next is now the D current. So this is 1728. And then you have to compute f of D and f dash of D again, which I am getting 35.6353. That is 35. Yeah, 35.63. 6353. And f dash of D is 5983.053. 5983.053. It's really simple. You just take the current value, which is 1728. The numerator is the function, the denominator is the derivatives. And then you put that here. You should get 0.1668, 1669. 0.1669. You can do one more iteration to see if this is changed, this will change significantly or not. 0.1669. 0.7000. 0.7000. And f dash of D is 5744.66. And based on that, you get 0.1667.
Should be a small, but
5744 point. So like we discussed during the lecture, you look at successive values and when they stop differing by much, you can figure out what the relative error is, which is so you can calculate what is the error, absolute, error, relative, which is, this is basically next minus current. Okay, with the just the magnitude. This will be next minus current divided by current times expressed as a percentage. So if you do that, by the time you are in the second iteration, your absolute error is minus 0.0012. So I'll summarize before I let you ask the question. Okay. The key thing about this problem is identify what equation to solve. Step one. Once you look at the equation, your instinct is it can be easily differentiated. So I will use Newton-Raphson because that's the method that is most fastest. Then you set up the problem, you compute its functions, the derivatives, and then what is a good initial guess to use? Most often, that is something you should choose based on that context. And in this particular problem, there is already a length scale h. So I'm going with half of h. Or you can even do 2 times h, it wouldn't matter. You will still converge quickly. So connect it to the problem in hand. Don't arbitrarily choose like 5 or 10 without any basis, because the value here is 0.21, which is half of h. And then do the iterations, keep looking at the absolute error, the relative error, When they fall between your chosen tolerance, below your chosen tolerance, you can stop. That's the general procedure. Did you have a question?
Yes. I'm a bit confused. Which one is your next and which one is your current? You're not linear.
This is next, this is current. And when I go to the next iteration, I put that here, this becomes current and I get a new next. Yes,
You had to rate the difficulty of this problem on a scale from 1 to 10, 10 being the most difficult, what would you give it?
this would be like a 5. So let's see if we can find a 7 or 8. Problem 8.45 from the textbook. 8.45. It's in page 223. That is a fluid, like a pipe flow problem. It may be complex, we'll see. Maybe too complex. Yeah, this I can't ask in a exam. This is just it's like a project. Okay, let's not do that. Anybody has any other problem that you want to see solved? Or I can pick one.
Can you some of the ones from chapter 8 that you were talking about?
Yeah, that's what we are doing. I mean, that's what I'm looking at right now.
You from chapter 6?
Yeah, sure. Chapter 6. Maybe we can just do a problem directly instead of doing the word problem.
Well, our exam should be work problems.
Word problems, yep. Let's try problem 6.20. Page 175, problem 6.20. Yes. Page 175, problem 6.20. Page 175, problem 6.20. The Manning equation can be written for a rectangular open channel as Q equals square root of S multiplied by BH to the 5/3 divided by mass or M. I shouldn't say mass, it's some M. Sorry, not M, like N. Multiplied by B plus 2H to the 2/3. Where Q is the flow rate in meter cube per second. Q is flow rate in units of meter cube per second. S is the slope, which is the ratio of two lengths. So meter over meter unitless. H is depth in meters. And N, lowercase n, is the Manning roughness coefficient, which is a number. Okay, it's a pure number. Develop a fixed point iteration scheme to solve this equation for H. So they are telling you solve for H. Given that Q equals 5 meter cube per second, S equals 0.0002 and N equals 0.03. Prove that your scheme converges for all initial guesses greater than or equal to 0. That's what they're asking you to prove. Sorry, which has unit?
Does B? No, B.
B. Let's see here. Oh, B is equal to 20. They don't have a unit for B. So B is 20.
What is?
They didn't say.
You're-
Or maybe I should say don't know, don't care. All right, so now you are given all the values except for H and you're asked to solve for it. Quick question, what method will you pick?
Do false point?
Sorry, louder.
Would you want to do false point?
False point, you can do, false point is a bracketing method. You can also do secant method, which will have faster convergence, but also has the small risk that it might diverge. You can try both. Okay. So if you're doing false point or if you're doing secant method, what is the small difference? So I'm writing two techniques here, false point and secant.
The range, I'll see if it's just finished, yes.
Need to specify a range, that contains the root. Kind of like bisection method, need just an initial gate. Both of them have the same equation to update the next value, which is, let me pull up that equation. So I'll write x, your favorite I plus 1, equal to xi minus f of xi, hold on. I'll write this next to the secant. Xi plus 1 equal to xi minus f of xi multiplied by xi minus xi minus 1 divided by f of xi minus f of xi minus 1. Yeah, that's correct. And then false point method. So false point method, xr equal to xu, x upper minus f of x upper, multiplied by x lower minus x upper divided by f of x lower minus f of x upper. And to put a picture next to this, here is x lower, here is x upper, and here is the approximate location of the root, where you have f of x lower and f of x upper. Clearly, x lower and x upper contain the root, which is xr. This picture corresponds to this method.
And XR is for false point, right?
XR is for false point. So all this is for false point. All this is for false. Here in false point, you have to locate the interval where you have to get a lower and upper. For secant method, you have to choose two guess values because you have to start from I minus 1. So you have to make two guess values. They don't have to contain the root, but you still need two values to calculate a slope. So can we simplify this? Like for example, substitute the values and see if something will make our life a little easier. Let's see here.
Did you have to solve for H, or could you move it over?
You need to solve for H, that's what is asked. So Q, which is phi, equal to square root of S, which is square root of 2 times 10 to the minus 4, multiplied by B, which is 20, power pi over 3, multiplied by H over pi over 3, divided by N, which is 3 times 10 to the minus 2, and then B is 20 plus 2H over 2/3, power 2/3. One simplification I can see is 10 to the minus 4, 10 to the minus 2, so that goes away. So you can rearrange all of this because you have all these are constants, right? So you can write try to simplify this. So I'll start another example. Problem 6.20. How do you simplify this?
Move it to the other side.
Right. So we'll write phi divided by square root of 2 multiplied by 3 divided by 20 to the 5/3. Okay, that is equal to H to the 5/3 divided by 20 plus 2H to the 2/3. You can also write this as H to the 5/3 minus this is going to be a constant, which is you can easily figure out what that constant is. Phi divided by square root of 2 times 3 divided by 20 raised to the power 5/3. 0.071977. Okay, multiplied by 20 plus 2H to the 2/3 equal to 0. So this equation is equivalent to solving this problem. Yes. Yes. So this is the equation you need to solve. Okay. At this point, you can even say I might be able to do it with Newton-Raphson. Okay, this equation is still not too bad for differentiation, but we'll still try it with false point method or secant method. So set up that table. Iteration number, current value, and then you have your f of h, and then next value, and then error. Set up this routine for all your problems. So which one shall we try? False point or secant? Shall we try secant? So you need two guess values, okay? And you also need to compute the value of the function at those guess values. Otherwise, then the next is given by this formula. So try one iteration, okay? You need two initial guesses, right? So let's try. If I put h equal to 0, what do I get? Negative. F of 0 or f of h equal to 0 is negative. What is f of h? Let's say h equals yeah, 1. Still negative?
You could graph it, you could use graphical methods today, I guess.
Right, that's right. So how does the graph look like? Can you come over here and draw it?
Oh, I have to graph.
Yeah. Oh, yeah. H equals 3.5. So people are watching, right?
So we'll look roughly, I'll draw it over here. So we know it's going to cross just before 1. Going to cross at around 0.75-ish. So 0.75. I'm sorry if my handwriting's.
I'll enlarge it later.
Okay, and then 1, and then it's going to cross, going roughly up like this. And then it continues going down, and it crosses this point out.
That is not relevant.
Oh, yeah, it doesn't matter. But that's
So this is between 0 and 0.75. Right. So thank you, Stephen. So if we graph the function, what we find is that this function here has a crossing point between 0 and 0.75. Okay, so an interval that you can guess. If you are doing the false point method, 0 and 0.75 can be used for lower and upper limits. Okay, if you are doing the secant method, it really doesn't matter which one you choose. You can choose any one that is in this vicinity. It will eventually pull you back here. So let's choose 0 and 1 as the two initial guesses we need. Okay, so we need 0 and 1 because secant method needs you to start from I minus 1. So what is f of 0? What is f of 1? We need to compute that. Sorry? Which both?
For if you plug in 0 in.
No, they can have any signs with respect to each other. They can both be negative or both positive or one negative, one positive, that's fine. So I'll call this -1 and 0. This iteration number, I'll call it -1. This iteration number, I'll call 0. I have guesses to be 0 and 1. And what is my function value? That is h to the 5/3 minus 0.5 0.071977 times 20 plus 2 times h raised to the power 2/3. Okay. What is my next value? That will be current minus f of current. Oops, no. That will be current minus f of current times x current minus x previous divided by the corresponding function. Work through this. I have the answer to Excel, but let's discuss after you've had a chance to try it. Yeah. I'm good. Yeah.
So in the actual exam, when we use the graphical method to like get a range or like a first initial value, can we like just graph it on our calculator and put it on here? Or do you want us to?
You can
actually
sketch it, but more importantly, what I want to see is you'll have to, if you are saying that my root is between 0 to 1, I need you to show me that f of 0 is negative
Okay.
and f of 1 is positive, or more generally speaking, if f of 0 times f of 1 is negative, then that means a root lies between 0 to 1. This has to be established,
Okay.
not just by showing the graph, but writing it out.
Okay.
Sorry?
I have a question as well. When we plug in the, so we take I or xi and then we subtract one from that, right?
Yeah.
Yeah, when we're solving for xi minus one, we
Yeah.
do that, and then when we input that into the function, it gives errors.
No, what is xi minus 1? You tell me.
It's your x initial.
It is 0. That is xi, when you're starting, when I is 1, x1 is this 1. X minus 1 is this. This iteration number is nothing but I. Maybe that hasn't been told explicitly, but this iteration is your I. Yes.
So when we do, trying to choose a range, can we narrow it down a bit more, because 0 is a bit off, it's kind of far over, so could I put it at like 0.25, just to narrow that range?
That is fine. You can, with reasonable resolution, you can say my root is probably between 0.3 and 0.8, and then squeeze it. It'll all take almost the same number of iterations. Because even if you get a very wide interval, the method will quickly narrow down on the root. So in a matter of 1 or 2 iterations, it will not be any different.
With the second method was, iteration always start at -1.
Yep.
Since it'll be at.
It'll always start with, you have to make 2 initial guesses, but those 2 guesses don't have to contain the root. Just for argument's sake, you can make this 2. you can make this guess to be 2 and this guess to be 3. It would still, it's like starting here. It will keep correcting the slope until it reaches here. You can try it actually. Yeah, actually, let me try it on my program. Yeah, it has no bearing on the answer. I'll show you that once I bring up my screen. So I can show you the Excel values if you want to cross check yours. Yeah. Okay. I also want to show you the values and maybe answer some of the questions about how to pick initial guesses and what to do, what not to do. All right, so listen, please. We have about 5-6 minutes, so please listen. So this is secant method on the left side. Okay. Whatever I call as iteration -1 and 0, these two iterations have to be guessed. That is, you have to pick. This is a guess. This is a guess, but the guess need not contain the root. So 0 to 1 need not contain the root. Let's make this guess to be something ridiculous, something like -30 and +20. Okay, we'll see what happens. -30 +20. Okay. What's happening here? Actually, it is very ridiculous. So we'll do maybe 2 and 3. So if I pick that, I calculate my function value at the current value, and then I have to do that twice before I can use the formula for next and compute the next value of the root. 1.15, 0.88, 73, 70, 702, 7022. By here, it has almost converged. Okay, if you apply a tolerance of 1e minus 6, if you add one more iteration, you are there. Okay. if I had picked a guess value of say 0.25, say 0.25 and 0.8, the only difference is I save about 2 iterations. And they are within 4 iterations instead of 6. So in the exam, if you use the graphical method to your advantage, you pick a reasonable guess so that you can get done sooner. Okay. So you need 2 guesses. Secant method, you need 2 starting guesses to get going, and then it will quickly converge. Once you get the root, once you get this 0.77022, you should substitute it back into the original problem to check if it's a correct convergence. It might converge to a wrong value also. Okay, so check that. False point iteration is much more secure in the sense that it will always converge, but it might take more iterations. So if I put 0 to 1 as my lower and upper limit, it converges not in 6, but I have to add one more. It converges in about 7 iterations. Okay, but there is no risk here, it will always converge. So I put this in the Excel file. I'll be sure to post this on the class web page. Yes.
Can you show what the function you use for this?
Yeah.
Again?
For the XR,
No, for just like F lower or F current.
yeah. H to the 5/3 minus 0.071977 times 20 plus 2h raised to the
So the lower was the function.
Well, F lower is function computed at lower, F upper is function computed at upper, F of XR is function computed at XR.
What's what would XR be then?
The XR is given by this formula,
Okay.
the false point formula. So this 0 to 1 is a guess, and this upper is a guess. Except that nothing else is a guess. Any questions before we close? All right, so you can expect word problems. Okay, that is definitely what 2 problems in the exam. All right, thank you.
Will you give us those, formulas, like for, false point and,
I might permit a cheat sheet.
okay.
Yeah.
Thank you.